Hi there. In this video, we're going to be going through how you can configure your own custom router and how you can do this in our chat interface. So first of all, you come to the website, unify.ai, then you press try now. And the first thing that happens is a question is asked. So what are some of the potential benefits of dynamically routing prompts to different LLMs? We see the router is already finished with the response, with all the stats come back. GPT-4 still going, so still taking its time answering the question at the bottom, so much slower. Let's look at the stats on the router. So the first thing we see here is that we have this, which is the importance placed on each of the 4 metrics by this router configuration. So what the router does is it decides which model and which provider to route to, depending on depending on how much you care about these different trade-offs. So each router configuration has a percentage importance for quality, for cost, for time to first token, and for inter-token latency, which all add up to 100%. And that's just a way of thinking, what's this router really trying to optimize for us? And we can see in this case, it doesn't care about the inter-token latency too much, cares a lot about the responsiveness, and it cares, equal parts about cost and quality as well. So then that's what these show. These shows the stats that were achieved for this particular prompt. So we were able to get 240 tokens per second. So even though ITL isn't explicitly optimized for, in this case, it was very good. So is the time to first token, and the cost also good there as well, e to the minus 4. So now let's compare that to the reference, which was GPT-4. So this was e to the minus 2, so about 100 times more expensive. Was also about 60% slower to get to the first token, and was about 10 times slower, almost 10 times slower, maybe 8 or 9 times slower on the tokens per second as well. So worse on all of these metrics. Now, of course, the quality is something that we can look into a little bit here. So what about the actual responses? Well, here we have optimization of resource and cost, improved response quality, scalability, flexibility. Yeah, these seem pretty sensible. Yeah, so what about on this side? Improved performance, increased flexibility, reduced computational resources, improved scalability. So very similar answers. So in this case, as we'll see with the benchmarks, we can do this more thoroughly, but just like playing around and getting intuition, it seems like the response here was good, similar to GPT-4, and we were able to do it much faster and much cheaper. Okay, so that's just a bit of a taster. So now if we want to have a lot more control over actually configuring our router, we can go to this compare interface. And what we get here, well, let's quickly go through the tutorial. So we have quite a few buttons here. This one enables us to select the dataset to view different benchmarks. This enables us to select the metric on the x-axis. By default, this is cost per million tokens, but it can be inter-token latency or time to first token. We can search for any specific endpoint on the left-hand side as well. We can select them here on the scroll down, so we can scroll through and see all of the different endpoints here as well. We can also select any of these on the graph on the right-hand side. So you can select endpoints directly on the graph and click on them to select for use in the chat interface. We can plot curves through the router points. I'll show you what that looks like later, but just to kind of connect the dots of the different router points. We can look at how each of the router configurations are using different models, and we can then plot for each of these stars, which are the routers, how many different models and providers it's using under the hood to kind of achieve this performance, basically. And then we can also change to API view, where we can see the code snippet for the selected endpoints or the selected routers and how to use that locally. And then once we're happy with the selections, we can press this, and then we can actually use the selections side by side and compare them like we just did a moment ago. And then also there's a video, so if you want to kind of go through, actually this will take you to this video, so you can click that. Otherwise, if you're happy, then you can just do got it, thanks. Okay, so let's actually look into this a bit more then. So we went through some of these main things. On the benchmark side, we have all of these. We have OpenHermes, GSM AK, Hellaswag, etc. So we can change these, and it will change the data set that everything's being plotted on. And we can select the metric. So by default, the x-axis is cost per million tokens, but we can change this to time to first token, or we can change it to inter-token latency. We can also change the axis to be log or linear. By default, having a log axis means that the points are spread more nicely, but linear obviously gives you a more intuitive feel for the relative magnitudes. In And then like a good starting point is to imagine, okay, well, let's say we did want to select the best router. We're on empty bench, let's say, and let's start with the cost graph. And we want to get a router that's pretty good for cost, quality, inter-token latency, and time to first token. And we want to be able to reason about, how good each of these are. So let's say, well, to start with, this one looks pretty good. Like, generally speaking, on all of these graphs, the best performing models are towards the top left, where the cost is high. So top and left, generally we want the cost and the latency and time to first token to be low. So the kind of top left of the graph is the sweet spot. So this one looks pretty good. We can kind of see in the box as well that this has, the values that come up here. This one looks quite good. Okay, let's see how this is doing on others. Time to first token. Okay, that's not great. I mean, let's maybe look at this as a reference as well. This one is much better time to first token. I'm also just going to actually, clear the previous router point we had. So let's quickly go here again. So let's look at this one. Let's look at this one, which is really good time to first token. And then what about inter-token latency? Yeah, let's look at one that's got really good inter-token latency that predominantly just sits on top of Llama 3 in this case. Okay, and then compare these. So then coming back to cost. Okay, so we can see here, again, this one, so 1 is very cheap, but not as good as 2 and 3 in terms of performance. Yeah, this is shown on the y-axis consistently. So 2 is the best for time to first token and 1 is the best for inter-token latency. But let's assume that we can't sacrifice quality. So 1 is not really a consideration. So the consideration then is between 1 and 2. Well, 2 is obviously better on the inter-token latency, which is typically more indicative of the overall speed than time to first token, which is just the initial responsiveness. And 2 is also better in terms of cost. So 2 looks like a better candidate than 1, but let's keep 1 anyway, just in case time to first token was really important because we're building an autopilot or we're building a code completion tool or an auto suggestion tool, and potentially just the responsiveness of the initial stream of tokens is potentially important. Okay, and then let's just compare these to, what should we compare to? Let's compare to, I guess Claude Haiku's maybe not a bad one to compare to here. Yeah, let's compare to GPT-4. Given that this came out quite recently. Okay, so we've got these. The other thing, as I mentioned, is we can look at the breakdown. So when we then hover over these router points, we can see what they're actually routing to. So let's look at this one in the case of 3, for example. What this means is that on this data set, this router configuration represented by this star, on average, uses these 4 models with these ratios. And this is done intelligently based on the prompt, so it's not just randomly sampling them or something. So basically, you can imagine that, 40% of the time it uses Llama 3 8B chat, 36% of the time it uses Mixtral 8 7B, 15% of the time it uses Mixtral 8 22B with Fireworks, and 9% of the time it uses Llama 3 70B with Together AI. And that's how we're able to use these 3. So you can see these 4 diamonds that appear when we hover over the router point. So these 4 diamonds appear. And you'll see that the router point is actually, up towards the top left relative to all of them. So we're able to get something that's better performing than any of them, and is cheaper than 3 out of 4 of them. And this is how you can leverage several models to actually get a performance cost profile that's superior to any one of these models, basically. So that's a good way of just visualizing what's actually going on with this router. Another way of thinking about this is it's almost like the variance of the router. So this router, represented by number 3, all it ever does is send a prompt to one of these 4 models. So your cost and quality will be represented by these 4 points. It's almost like a way of visualizing the distribution to some extent. I mean, these are 4 values that are the means for the 4 models and providers, but it gives you a bit of a sense of the bounds at which you can expect the cost to look like and the quality for the routing configuration as well. In the case of 2 basically is 100% using this one, and a tiny amount uses Mixtral latex 7B basically. Another thing worth mentioning here is that even a router that uses mainly defaults to one model, this can change over time as new models come onto the scene all the time. this router configuration that balances, cost, quality, and speed at these levels, that fixed router configuration might change when a new model comes out, and it will then improve with the new model, and maybe it starts to then mix between several again. So using the router is not only about improving over the endpoints today, but it's about specifying your needs in terms of balancing these things, rather than just like locking yourself into one model and one provider, and actually being able to ride the wave of new updates in a kind of abstracted way, basically. Okay, anyway, so this is how you can select them. You can also plot curves like so and just like see the line connecting the router, if that helps for trends and stuff. And I think this is everything that's worth going through on this side. So let's now just have a comparison. So let's now ask another question, which is, let's say, let's ask another question, like, what are some of the benefits of there being several LM providers, not only one? Let's see what I think about this. So the two routers and GPT-4o off to the races. The first router is already done. The second router is now already done. GPT-4o is still going, despite being obviously twice as fast as GPT-4 and cheaper. So now we have, so the first router here selected was able to get 210 tokens per second, 0.9 time to first token, and e to the minus 4 on the cost. So this is then ends up being still about, in this case, about 60 times cheaper than GPT-4o. It was about kind of 7 or 8 times, maybe 6 or 7 times faster in terms of tokens per second, and also quicker to get the first token. And then this router, again, you can look at the numbers here, was about twice as fast in tokens per second, was about twice as fast in terms of time to first token, and was about 1/3 of the price. So yeah, that's the first thing, the raw statistics. You can again look at how these routers are balancing these different factors. You can also see here on the training set of this router what it would typically, which models and providers it would typically route to. This is not quite the same as the values that are plotted on the previous graph, where it's all in reference to whatever test data set is being selected for the scatter graph. Because here we're testing these routers in the wild, these percentage values are in reference to the training data that this router was trained on, and how often it would typically be selecting these different models in that prompt distribution, basically. So having a look at the answers again, so we have having multiple large language model providers can bring several benefits: increased innovation, competition and cost reduction, diverse perspective approaches. So yeah, seems pretty good. Competition quality, I'm not sure about networking opportunities. It's a slightly strange one. Geographic diversity, flexibility, etc. And then GPT-4o, innovation and competition. So that was quite similar here. Increased innovation, competition, diverse approaches. So again, very similar answers, like intuitively playing around. And that's the main benefit of using the chat, is not to do rigorous exhaustive benchmarks. That's what the graphs are there for. And actually in the next video, we'll be talking about how you can upload your own custom prompt dataset in order to actually get rigorous evaluations on your own prompt data for your own task, and actually get quantitative comparisons between different routers and different endpoints on the task you care about. The main benefit of this chat interface is really just to play around and get an intuition. So if you have a task and you have a prompt data set, rather than doing a big exhaustive benchmark, you can just say, okay, well, let's just copy and paste one of the prompts into here, see what these routers do for this one, and start to just like look at the responses, look at the speed, and start to gain an intuition for which router configuration might be best, which is a complementary addition to the kind of out and out number crunching that you can do with the benchmarks, and as we'll see in the next video, you can do on your own custom prompt data set. Okay, well, this video is already getting quite long, so I'll wrap up here, but hopefully this just gave you a quick overview of what you can do with the chat interface here, gave you an overview of how you can select different endpoints. One thing we didn't mention was that you can select them here as well, so you can search here. This will then limit the search space of the window on the right. If you use quotes, it will then do an exact match, so Llama 3, for example, whereas if you do it without the quotes, it will also bring you Well, yeah, maybe not here, but it'll bring you a few others. Yeah, so this is kind of the main interface explained. But if anything's unclear, obviously, then feel free to just message in the Discord. I'm online pretty much all the time, so you can find our Discord here. Oh no, sorry, the Discord. Yeah, here exactly. So you can find it here, and just message in any of the channels, and someone on the team will respond quickly. Also, when you sign up, feel free to email me any questions and stuff. Cool. Anyway, hopefully that made sense. Really excited to be getting this out there and hearing what everybody thinks. Would love to hear feedback, positive and negative. If things don't make sense, let us know. But yeah, for now, thank you very much for watching, and I'll see you in the next video. Bye for now.